Now I will make a short presentation of what is the ECHORD, and then we will go through the process of these PCPs, how is the documentation and administrative issues, and then we'll go to the functionalities of the challenge that has to be resolved in the challenge. And then afterward is our open questions for you, and if any of you want to make short presentation of your company, or you can do that at the end of the presentation. Then later on we will go to visit the SeaWorld in Barcelona, where the place then can be doing the experimentation, and you will see how it is actually real. You have seen probably the video, but actually you can see the present situation. Okay. Well, ECHORD++ is a European project in FP7 program, and then it promotes robotic innovation by facilitating the cooperation between public administration, academia, and industry. And it has three instruments. One is experiment, another is robotics facilities, and the third one is the pre-commercial procurement, the PCP pilots, what we call. The experiments has been oriented to make robotic solutions to different areas. Actually, we have selected three areas. One is robots in industry, robots in healthcare, and robots in robot services, in different kind of agriculture, different kind of service, urban, etc. Actually, we launched the first call in 3 of March. This was closed in the 14th of April, and the evaluation was done in May and June. Selection in 30 of September, and the start of experiment will be on the 1st of January of next year. And each one of the projects around is 300,000 euros for the experiments, and that runtime is 18 months. It's going to be a second call for experiments in around June next year, and then also in any of these areas. Okay, they were presented around 140 proposals, and then we selected 16 experiments, around 40 partners, different consortia of more than one partner, 2 or 3 partners from different areas, from different sectors, from academia, from industry, from different. And then 13 of these have used E++ RIFs or robotics innovation facilities. We have 3 robotic innovation facilities, one in Bristol about robotics, robots applied to industry, another in Paris for healthcare, robotics in healthcare, and the third one in Pontevedra, close to Pisa, robotics for services. And these RIFs has provide platforms, robots, installation, infrastructure, in order that you can make trials. That is basically for experiments. But anyway, if any of the consortium wants to use these facilities, can also use these facilities in the project. If you need some specific material that you do not have, you can apply for one of these groups. Okay, the PCP is, we have selected 2 scenarios, the PCPs. One is in urban robotics, and another is in healthcare. Today we will present both. Basically, the urban one, that is the call, but also in the last we will present the healthcare one, in order that you have also additional information about that. There will be an info day in the 5th of December, no, the 3rd of December in Munich about this info day. Okay, this scenario, the objective is to find challenges proposed by public bodies in urban robotics in healthcare, and select one of these, and this will be the one that will be applied. Actually, in healthcare, in urban robotics, what we did is analyze and select public demand needs actually that public bodies require, and this we did by networking in academic rounds and talking directly with public bodies, and then we make we contact with these public bodies, and then we ask them to send proposals, challenge proposals. And from this challenge, there were sent 18 from healthcare robotic challenge and 14 for urban robotic challenge. And then from there, an expert panel select one challenge for healthcare, one challenge for urban robotics. And this is the challenge is the one that we will talk today. And this challenge, the call for this will be the 15th of January. That will be open the call. Okay. Now, in order that you have additional information, in order to select this urban robotics, we analyze with the public body 40 different urban needs, and from this we receive 14 specific challenges, urban challenge. And from this challenge, it was selected the SeaWorld one. For these 14 challenges selected. Actually, the other ones are very, very interesting. And actually, the score that they got was very high in order to be. But finally, the top one was the SeaWorld one. Okay, this is the one that we will talk in detail today. But we did exactly the same for in a different format for healthcare, and there appear 18 potential challenge, and then again an expert panel select one of these, and the one that was selected was the robotic geriatric assessment, the comprehensive geriatric assessment that also will be presented today in order that you have information about this challenge. Okay, all this information will be available in order that you have all the slides will be available, and we will provide additional information by the 15th of December. All right, yes. The 15th of December, you will have all the documentation in order that you can prepare your proposal, and the call will be open on the 15th of January and will be closed the 28th of February. Okay, you will have 6 weeks to prepare your proposal. Today we will explain all the details, but if you have any questions, please ask us in order that we can explain as much detail as in order that you can make an excellent proposal. That is what we want, to have excellent proposals in this, and to select 3 of them that will go for the first phase, and 2 of them will go up to the end of the project. But we want excellent proposals. Please ask us everything that you need in order to get this proposal. Okay, it is everything for me, and now we will go. Yes.
Let me introduce you a little about the process of PCP. Alberto explain a little what have we done during this year and what we are going to do during the next 4 years of the project. ECHORD is a project of 5 years, from 2013 to 2018. We have started on October 2013, and yes, we have these 3 main instruments, and today we are going to speak about the pre-commercial procurement PCP pilots that want to bridge the technical innovation through public demand, identifying the cities and citizens' needs, very important, selecting the tailor-made high-quality robotic technology is your work, and to close the gap between demand and supply. So in the typical relation between industry and academy that I think you know perfectly, now the European Commission, not now, in 2007, they decided to introduce the public entities, the public bodies, in order to know exactly the demand and join the research with the demand, the exact demand of the public entities. 2 scenarios, urban robotics and healthcare, and a process that ECHORD presents with around 8 steps, 8 phases. This process starts with the selection of robotic challenges and public bodies, and we are now in the middle of, well, we have finished this part of the process, and now we start the pre-commercial procurement. Let me explain you a little what does it mean, because it's not very easy, the process of a PCP, and I think it's interesting to speak about it today. The product innovation life cycle have normally these 4 phases. The first one is a curiosity-driven research. It's an active search of needs and challenges. What do you need? A hospital. What do you need? A doctor. What citizens? What do you need for your city? This is the phase 0. The phase 1, phase 2, and phase 3 are the phase for a pre-commercial procurement. And we will arrive with this pre-commercial procurement with a pre-product. We won't arrive to a product. We will arrive to a pre-product. These 3 phases are a narrowing down phases. So it means that we start with several proposals selected, and we will go narrowing down these proposals to arrive at least at 2 proposals. Why at 2 proposals? Because if not, the public entity cannot do a normal procurement for this product. So they need competitive situation between several offers, and we need to arrive to 2 proposals. So what ECHORD starts now, today, ECHORD starts this pre-commercial procurement with these 3 phases. The phase 1 with a solution exploration. We will select 3. In another PCPs, you can select 5. You can see different quantity of proposals selected. We will have solutions designs, 3 solution designs. In the phase 2, we will do the prototyping. From the 3 first selected proposals, we will select 2 with an evaluation and selection of an expert panel, not by us, by an expert panel. We will have 2 prototypes, and these 2 prototypes will arrive in the 3rd phase to the self-test field self-test. So we will arrive to a pre-commercial procurement, and what happens with the public entity or public body that is with us during all this process, that in this moment they can do a PPI, they can do a public procurement for commercial rollout, and they can buy the solutions. So not only is interesting because they can buy the solutions after this pre-commercial procurement, but also because the scalability of these products could be incredible. So the pre-commercial procurement is a process, is a procedure that Europe want to use. Europe want that public entities present public pre-commercial procurement, and ECHORD is one of the projects that try to improve, to increase this ideal situation for innovation, for technical innovation. So this is the 3 phases of the PCP. And we are now here with our call for research and technological development. Okay, we are here. We have worked during 1 year. Alberto explained a little what have we done. I will explain a little also this phase 0. But let me present you the 3 phases, the 3 phases of the pre-commercial procurement that are the phase 1, the RTD activities. With solutions designs, the runtime will be 6 months, and the consortia will be selected 3 by scenario. So 3 consortia in healthcare and 3 consortia for urban challenge, sewer inspection and maintenance. The budget 42,000 euros for consortium, for each consortium that will be selected. This is the phase 1. The phase 2 is the prototype development. The runtime is 12 months. The consortia will be selected from the 3 first 2. We will select 2 of them, and the budget is 145,000 euros per consortium. And the phase 3 is the small-scale test series with a runtime of 12 months and the same consortia that have done the prototype, and with a budget of 290,000 euros for consortium. For us, it's very important also to know your opinion about this process. If for you it's okay, 6 months in the first, 12 and 12. This is what ECHORD presents, but today are also open to discuss with you about the process, about the timeline of the process. So please, after our presentation, don't hesitate to propose and to taste or to say what you think about. Only for you to know exactly what have we done during the Fase Zero, because we have worked during practically 1 year with public entities. We start with needs at the Smart City World Congress of 2013, last year in October here in Barcelona. We took all the memories and we tried to understand exactly what cities needed, and we arrived to several considerations. A first list of needs that we wanted to arrive to become a challenge, robotic challenge, not a challenge, because it's not the same to have challenge at the cities than to have robotic challenge. So we have worked with these public entities, explaining what robotics is. That is not easy for them to understand because they know nothing about robotics. And after this work with them, we have arrived to a proposal, 14 proposals from cities. All of them are very, very interesting. Now you have here only the name, but the presentation were about 4 pages of their need and the function that they need for the new technology. So very, very well explained and very close to what can be a public procurement for innovation, for technological innovation. So from these 14 proposals, an expert panel in September select the utilities infrastructure condition monitoring seaward inspection as the ECHORD++ urban challenge best. And after this, we are going to develop this challenge with our first call next January. The result was this challenge in urban robotics, and the city selected was Barcelona City Council and Becasa. The proposal came from Becasa. Becasa, I will present you later on, and we will have here the representatives of Becasa during the morning. Barcelona Cicla del Agua water cycle is a company created by the City Council of Barcelona that manages the entire city urban water cycle and provides direct and indirectly services related to the water cycle, to the beaches, and to the coastline and the environment. The challenge that they proposed were centered in seaward inspection, not beaches. The company is attached to the Deputy of Environment and Urban Services within the Urban Habitat Department and perform its functions under the leadership, supervision, and control of the Water Cycle Services Direction. Okay. Okay, this is the same we have seen now with our challenge. Now we have the challenge robots for inspection and the clearance of the seaward network in cities. And we have the call for research and technological proposals on January 15, and we will end it at February 28, and we will have all the call documentation on December 15. We will try to, because the time for this part of the process has been very, very short. So also for the call, for the info day, sorry for this, but we will have this information. Only to know more or less what we have asked at the experiments call. Here you have more or less the template, the research solution objective, the progress beyond the current state of the technology, the concept, methodology, and associated work plan, a task list, description of individual tasks. Don't forget that we are in a call of the European Commission. It's more or less the same that the European Commission asked for the calls. So we are managing this call, but this is an European Commission call. Don't forget it, please. The list of deliverables, the summary of experiment, well, in this case, the summary of experiment effort in persons month, PM, list of milestones, impact, implementation, and business plan. It's very important for us, the business plan, also because we want to know if we have really success in our proposals, what will happen with the two pre-products that we will arrive to have. The business plan can give us an idea about if the possibilities to have a commercial one are, and this is very important also for this project because we want to have new products at the market, and not only to improve and increase technological solutions, technological innovation, but also to have new products and robotic products at the market. The evaluation criteria, more or less, we are now working in this, but the scientific and technological excellence, more or less, is the same as all the European projects that if you use to work with European projects, is more or less the same. The efficiency of the implementation, the expected impact. Okay, well, you will have it. And only 3 words for the advantage for small and medium enterprises. You know that Europe wants to go better in the way of to increase the work of these SM enterprises, and only few words about that you can implement your innovation, pilot your solution to prove its value directly to decision makers, very, very important, evaluate its impact, gather intelligence for product development, and gain a validated market reference. So this is what are we trying to give to you. Marketing opportunity and international exposure. Present your solutions directly for evaluation by decision makers. We will have the public body during all the process. The public body in ECHORD is financed also, and they will be with us monitoring all the process. Meet key city leaders. In this case, you will meet all the Becasa leaders today, and all along the project, I think Maria Jose and all the team of Becasa will be with us, so you can have the inputs and what they think about what are you doing. The connection to stakeholders. In our case, the connection is directly with the public entity, not with citizens, but is very important. And the support in search for investors. So ECHORD++ PCP pilots creates opportunity to reach out to potential investors and funders of the innovation, and works carefully to ensure that the innovation will answer real demand. That is what Europe asks us. Okay, so save the dates. The info day of today is the info day in urban robotics. The next info day is the 3rd in Munich for healthcare challenge, and the call will be in January 15, and we will inform you about all the dates that are important. All the information in our website, ECHORD.eu. Thank you. Nothing else. If it's okay for you, I don't know if we have questions now, or I prefer perhaps that Maria Luis perhaps can open more this process, all the things related to administrative documentation, and after we make a little part of questions. Thank you.
Can I ask something?
Oh, yes.
You included a company D in the first phase. You said that only 3 companies.
Yes, I include one because I wanted to explain you what a PCP is. And perhaps a PCP has in the first phase 5, 6, 7, or 8 companies, but ECHORD only 3.
Okay. So the fourth is irrelevant to this call.
Yes, the fourth is irrelevant in this case. It's only to show you that the PCP normally have a narrowing down process. It starts perhaps with 8 or 6. They arrive to 5, 4, and then they arrive to 3, 2, or no, the number is not exactly as ECHORD presents. No? ECHORD presents 3, 2, and 2.
So maybe I start a little bit with introducing myself. My name is Marie-Louise Neitz. I'm coming from the Technical University of Munich. I'm leading the ECHORD++ project together with my scientific colleague Reinhard Lachrenz, and I'm more or less replacing Professor Knoll today, who is the coordinator of this European project. Maybe just one word in addition to what Alberto has already outlined. The total funding volume of ECHORD++ over the 5 years is about 20 million euro. So it's fair to say that this is probably one of the biggest European projects on robotics. And that's why we have a specific, we are scrutinized by the national contact points, but it's a fairly high profile project at the European Commission. We have been talking about the PCP and the PCP pilots and so on and so forth for quite a while now. Maybe I would like to explain you a little bit about the history, because the intention, when we wrote and submitted the proposal, the intention of our initiative was to find a way to ideally, or to integrate public bodies in an ideal way in the technology development for the public sector. We have done this because we believe, it's our strong belief, that there is a tremendous market potential on the public side that we can tap to a certain extent with robotics technology. And that is why we integrated this instrument in the proposal. But there is a difference between the PCP, as you might know that, and the PCP pilots that we will implement in ECHORD++. This will have the difference will have impact on funding, on the administrative part, and also on the way how we handle the financial issues and how we do the monitoring of the technology development during the technology development phase. So what we wanted is, we have ECHORD++ is a follow-up project on ECHORD, which has been running for 5 years before. This project just implemented or just included the experiments, and we had very positive experiences with the experiments, and we wanted to implement this scheme on the development of technology development for the public sector, and that is exactly what we want to do in ECHORD++. This is something that we have heard already, so we'll skip that. As Anna already explained, we have selected, or our independent experts have selected, 2 different challenges, one in urban robotics and one in healthcare. On the 15th of January, we are going to open an open call for RTD proposals. So it's not a call for tender, it's a call for proposals, which is the difference. We would like to, we have discussed internally which skills we think would be good to have in the consortia applying for funding starting 15th of January. So we feel, and this is very important, it's a speciality of ECHORD++ and the experiments, and this will also be a speciality of the PCP pilots. You can have national consortia. So you don't need to look for international partnership. You can work with people that you know close by, as long as you are you have complementary skills and present a strong proposal. So nationality is not an issue. The abilities and the knowledge that we think would be desirable to have at a consortium is, you will need to have the ability to assess the feasibility of the project technology. So you develop a technology, and during the runtime, you have to have the ability to see whether the technology that you develop really fulfills the need of the public body. And the public body will accompany the entire process to make sure and steer the technology development process during the runtime. Then it would be good that you have the opportunity, the skill to know how you would like to position the final product that you develop on the market of reference. So you need to know the rival products, you need to know which kind of technology components is already available on the market and at which TRL level they are, so that you know the competition that you will probably face or have to face in the future. I think cost efficiency is always an issue when we are talking about collaboration with the public sector, and it's good that that you have people on your consortium who know which components they can address in order to reduce the cost of the technology development and to provide a cost-effective solution. And it's not necessarily in the very first place a research project. I think it is a project where you will have a certain degree of system integration as well, using technology that is already on the market and trying to combine components in an ideal way in order to fulfill the need of the public body in sewer inspection. The administrative procedure. As we have already outlined, we are going to open an open call for RTD proposals 15th of January. Then we will select independent experts, will evaluate those proposals, who will have a selection panel at the end, and they will select 3 consortia per challenge. The people selected, the consortia selected, will join ECHORD++ via an amendment. So who you will become, the people who have been successful will become part of the project, being integrated via an amendment. And now I have a question. Does everybody know what an amendment is and how that works? Because that is decisive to a certain extent. So you are familiar with the scheme. Okay. Yeah?
No.
Yeah? No?
If you can say a few words.
Okay. So our collaboration between ECHORD++ and the European Commission is based on a grant agreement. So each European project has a number, an identification number, and this is the grant agreement number. This is our contract. In addition to that, you have within the core consortium a consortium agreement where it's regulated which kind of rights we have, who belong the technology development, who can use it, and things like that. When we select people or independent experts, evaluate the proposals, and pick the people with the strongest proposals to become, let's say, the partners to develop the technology, those people need to get registered. If they have not already been registered, we call it validated, with the European Commission, and then you get an identification code. You need to submit some kind of documentation which concerning your status, whether you are an SME or a large company or research institution or whatever. And based on this, you will get validated, and this validation has an impact on the funding that you will get. So you have either 55%, because it's an FP7 project still, you have either 75% funding or 50% funding on RTD, and you have a specific and different indirect cost model, working with flat rates or with actual indirect costs. And this depends on the kind of institution that you are. And this will be validated with the European Commission. This can be a time-consuming process, but as we have in ECHORD and also in ECHORD++ quite a lot long-standing experience in this, we have personal and direct contact to the people from the validation team, and that's why we are able to speed up the process and to help you with your validation process. and I will come to that in a second, will also take all the administrative burden from you to the extent possible, will reduce the reporting load to the absolute minimum, and I will just say a few words about that as well, in order for you to concentrate on the research and on the technology development, because that is what we want from you and what we need from you, not the administration. That will be our part. So we have a consortium agreement in ECHORD++ for the core consortium, which stipulates that for the consortia that were doing the technology development, they will have the IP rights of this technology development. It will not be the public body. It will be yours afterwards, and you can exploit that. So the public body will be there because they are interested in using the technology afterwards, and they will help you to find a way, to find a design that absolutely fulfills the need of the public body that they have. Then, and this is mandatory because for PCP, because we want to make sure that we don't have any trouble afterwards. There will be a consortium agreement for the technology development consortia as well. We will provide a draft that you can use. You can modify the draft and everything, but what is important for us is that you do that, because if you tap a huge market potential, and that is what we would like to reach, we would like to reach this point that it is a huge market potential that you can tap afterwards, then it must be clear who has which rights in the consortium. Then we have the funding scheme. As Anna already explained, we have 3 different phases, and we will allocate the budget always for the respective phase. And we want to regulate this via a framework agreement, and that is something that we are already working on, or still working on right now. So you will have a framework agreement which regulates the budget allocation for the 3 different phases. This is because the budget, I mean, we will start with 3 consortia per challenge at the beginning, but those will be reduced based on milestone reviews. So we cannot allocate the budget for the entire runtime at the start, at the beginning, because we can only allocate for the first 6 months at the first step, and then second phase and third phase. Then we have also a budget for the public bodies, which is not tremendous, but at least it helps to cover some travel expenses and also some effort that the public bodies will invest in this project. And as you see from the different phases, the share of the equipment that you have in the budget increases. It's just, I mean, it's just an indicative budget, but the tendency is that it increases as closer you come to the small scale test series. The amendment process is something that I've already outlined very briefly. So you will need a pick. You can apply for a provisional pick at the moment when you want to submit a proposal. For the permanent pick, will help you afterwards with the validation process. You will have your indirect cost model as in FP7, and we will collect all the information by template or with templates that we need to get you into the NEF system of the European Commission. So you don't need to do anything apart, let's say, more or less, from completing Excel sheets for us and submitting those on time. Yeah. So, and we are in very close contact with the validation team, so we know exactly which kind of data and documents they would need. And we can facilitate this process because you have someone at our team whom you can call. So you can send us direct emails, you can call us, and we will answer your questions if you have them. The funding. We are going to give you pre-financing for the individual phases. So hardware, durable equipment, and consumables will be pre-funded at 100%. With a cost capping, and I would like to come to that point in a few seconds. And then would like to have 40% in personnel costs and travel expenses, pre-funded for the individual phases. Then we have the indirect cost model, as already explained, based on the validation. And after that, you will have the possibility to claim your costs based on cost claims, which is the regular process in European funded projects. Again, we will help you to facilitate this process, and we have a platform where you can enter all your costs, so you don't need to to struggle with a couple of things that normally in European projects are not always so smooth. And then we have the reporting period starting or counting from 1st of October 2013. Our reporting periods are 21st, 37, 49, and 16 months. Before I come to this point, I would like to explain a little bit how we would like to monitor the progress of the different groups working on the RTD technology development. We are going to, for our experiments, we have a platform, a monitoring platform. Based on our experience with ECHORD, we have, I think, quite drastically changed that. So we will have a monitoring session with you every 2 months, but there will be no reports. What we would like to define with you in advance is which kind, based on the technology development that you are doing, which kind of data you can share with us at which point in the technology development, which allows us to check what you are doing without having any obligation for you to write lengthy reports. So what we are thinking about, you can send us videos, you can send us pictures, you can send us simulation, you can send us software data, whatever you like. But the only thing is we would like to know that in advance so that we know which kind of data we would define the technological features that you will concentrate on in your development. And based on this, we will define together with you in the negotiation phase which kind of material you are going to share with us at which point, so that we can know what you're doing, and you can concentrate on the research rather than writing reports. And I hope that this will work well. We are doing that with the experiments right now, and I have the impression that reaction is quite positive. So Anna explained that we would like to support you afterwards in the exploitation of your technology by also, I mean, we have already contacts to more than 3,000 institutions, and we will use those contacts to increase the impact at the end. So we will make our contribution as well, and we will try to support you in getting those technology on the market. We also have contacts with venture capitalists, and so we have a different kind of people. We are fairly well networked, and we are quite highly ranked at the European Commission, and they are very open and very willing to support us in our initiative, because ECHORD++ is one of the flagship projects of the European Commission, and this can be an advantage for those people working in the project. All what we would like to have or to reach is to create the impact in urban robotics with our initiative. And this is a statement from the CEO of Red Zone Robotics. Robotics has lots of opportunities in the future because the cost curves have come down to a point where robots can help solve real marketplace problems. There's a very huge market for cost-effective solutions, which doesn't mean cheap, but cost-effective also in comparison to what you would have to invest if you would like to continue with manpower. They need tailor-made products, are expected to optimize the public economic resources. And ECHORD++ and its network will help proposers to tap this market potential. Thank you very much for your attention, and we would like to answer your questions if you have any. Okay. Everything clear?
Yes.
Yeah? Okay. So if you feel that afterwards you have something that you would like to discuss, or you can find me at lunch break and also at coffee break.
Okay. To the CASA team, first of all, and Albert Vilalta is the conciliar of the board of directors of the CASA. Thank you, Albert, to be here with us. I think ECHORD is a very nice project, and the CASA is a good company to be with us. Gustavo Ramon is the operation director. Thank you, Gustavo. Josep Garriga is the head of inspection service. So you have all the team of the CASA in order to ask them questions or what you need. And Maria Jose Chesa is the head of research, development, and innovation. And the team of Maria Jose is Ana Llopart and Lina Martinez that are also here. So thank you to all of you, and it's your time.
Hello, morning. We start our presentation with some introduction about the CASA, Barcelona water cycle, some data results about sanitation, the specific challenge in urban robotics, the functions of the new technology, and the impacts that we expect. The Barcelona water cycle mission is to manage, coordinate, monitor, optimize with quality, sustainability, participation, the provision of integrated water cycle services like supply, sanitation, integrated coastal management. All these commitments are organized to improve the environment and fight to the climate change to achieve a sustainable, improved quality of life for citizens. The strategic lines of the CASA are promote some policies in order to reduce water consumption, promote policies to improve urban drainage, promote policies to improve the integrated management of the coast. Every line strategic has the important policies that for water consumption, ensuring rational use, ensuring the quality of supply, and promoting the improvement of the development of the entire water cycle system, and collaborate with other administrations in the development of the hydraulic plants and projects. About the urban drainage, improving the quality and the extension of the sewer system, controlling and supervising the management of the sewer network, and improving and extending the control and supervision of condition of the sewage system. In the integrated coastal management, it's important to promote the new culture of the beach for citizens and tourists, coordinating all the operators and improving the services offered. The main objectives in the water sanitation are the planification and inspection of the sewer system, the control and monitor of the condition of the sewer network, coordinate the work schedule cleaning of the sewer network, manage, monitor, and inspect project and restoration of the network, supervise the construction of private drains, all private works, manage, monitor, and inspect the projects and works of all kinds of sanitation, collect data, and prepare studies of rainfall and other impacts on the sewage network. And at last, develop regulation on building materials and construction techniques of the network to ensure its uniformity. Barcelona, about the main data for the sewer network. Barcelona has a combined sewage system network, and sometimes there is a problem for its management. The total extension of the sewer network is about 1,500 kilometers, and with 1,000 of manholes, drains, connections, and a lot of different instruments, and 15 water tanks to control the rainfall episodes. And other data, there are important extension of optical fiber inside the galleries of sewer system. It's important to reflect that the management of the sewer networks consists in several tasks. The cleaning of existing network, the reconstruction and rehabilitation of the existing network, the sewer inspection, and the advancement management of the sewer network. All these activities cost an important budget for the municipalities. In the case of Barcelona City, the cost of the sewer inspection is about 1 million euros per year, and it represents the 12-50% of the total budget for sewer works, for sewer management. About this specific challenge in urban robotics, it's important to explain that the work inside the sewer network is very hard and unhealthy for the staff, because the conditions inside these places are very extreme sometimes. And introducing a robotic solution could improve on these labor risks, and could improve the quality, the precision of the sewer inspection, and could optimize the sewer cleaning resources in the city. The robot should determine the quantity of sediments in the sewer to define cleaning schedule. Other proposed functions could be defects identification, cartography, and monitoring and sampling. These functions that we ask for in the new technology are sediment inspection, identification of structural defects, sewer monitoring, and water, air, and sediment sampling. At last, it's important to ask for the sewer cartography. About maybe the most important function is the sediment inspection for the volume that it requires. And it's important to talk about the robot autonomy that we think it could be interesting, minimum 4 hours battery. About the trail that the robot should be make in every day. The optimum could be 3,000 meters in 8 hours, and the minimum 1,500 meters in 8 hours. About the conditions inside the sewer system, it's necessary to explain that for small pipe sizes, the technology sometimes the state of the art are good results with a small diameter, but from diameters from 80 centimeters, the results are not good. We need more. We need this technology. And it's necessary to explain that to enter inside the sewer system, we have the manholes with this size. Another function is the identification of structural defects that I explained now. Another condition for this new technology is the cost. We can talk about a new technology, fantastic technology, but it's impossible to use because the price is not appropriate. And about this, we think that all the service this technology should be less than 50 cents, with all included. In this moment, for these inspections with the staff, we need four people for these works. We think that the new technology, we can optimize this work, and the price could be about this order. About the sediment inspection in the sewer system of Barcelona City, we have a lot of special sizes and different situations that we will describe very clearly in our document challenge area. I'll show you some examples about these sediment inspections. Another function that we propose is identify critical structural defects and his location using the European regulation for this function. You can see the different structural defects that we hope the urban robotics could improve in our services. Other proposal function will be the sewer monitoring to have to avoid the access to sewers in the at-risk situation, and to improve the health and safety measures for the staff. About the sewer monitoring, we propose different sensors, air sensors, water sensor, and general functions. And this function aims to make decisions without exposing to the risk situation to our staff. Sometimes the sediment sampling is very important to make good environment policy, to identify the different industries or different companies that don't make good things that you can see in this image. And it's very interesting to have the samples with the specific compounds, and sometimes it's very dangerous for our staff make these samples. And we think that with this new technology we can improve this service. There are other examples about this, the water, air, and sediment sampling. About the other function that we propose is the sewer cartography. And we hope that this new technology could give accurate knowledge about the actual infrastructure. This function could help develop us the hydraulic models, making more efficient all this operation, and provides greater flexibility in the distribution of information for our knowledge and to share with the external requirements. And this sewer cartography could help the management and the rehabilitation of our sewer system. There are some pictures about the singularities of the sewer system and the difficulty to work inside, with slope changes, with connection in different levels. At last, the different impacts that we expect. We expect a social and cultural impact, environment, economic, innovation, and we think that is very realistic, execute all these functions that we thought. Thank you very much.
Thank you.
the sewer gallery that we will visit this afternoon is different. That it's easier. This is easier.
Inspect and also to
It's prepared for visit. It's a touristical sewer system network.
So
It's nice, it's very clean.
But here we want to show the difficulties
Yes,
and
of
the
course.
characteristics of the sewer system of Barcelona.
we have to.
Different diameter and size sewers network. You see here the wastewater.
The light is also important because it's the
Yes.
man that is.
Yes, it's with a light on light. If not, it's with no light.
There are no
inside.
light
Yes,
inside.
basically. You can see here some stairs, some different characteristics inside the. This is basically the visitable network. Part of these, there are the not visitable, the smallest diameters. Well, here we can see a detention tank. These big collectors are the collectors near the sea. Yes, the collectors are right to the interceptor, the collector interceptor that sends the water to the wastewater treatment plant, and finally the exit to the sea, to the beaches.
Finish.
Thank you very much, Maria Jose. Well, I haven't been introduced before. Let me introduce myself. My name is Antonio Grau. I'm with the Technical University of Catalonia. I'm with the ECHORD staff. And well, our role is obviously to manage the ECHORD project and also to be monitoring all the experiments and also the projects that will be present and also the winners, those that will be selected to develop the challenge that will be also monitored by us. We have been seeing this part, the technical part. This moment has been very, very technical. And let me only show just a couple of slides to not to say what you have to do, because you are the experts. You will be the experts and you'll be preparing the proposals, but also to focus the problem. No? The problem, I haven't seen anyone running away after the video, and this is very important because our role is to encourage that you prepare, independently of how tough have you seen the project or the challenge or even the video. There are a lot of things to do, and we hope that you as experts and other experts that will be presenting the proposals, you will know how to manage this challenge. Maria Jose presented those insights, and I want to focus, to emphasize the last one, I'm sorry, the ability to execute. The ability to execute at the end is we expect some realistic projects. Even though it's a research project, at the end, some prototypes or some equipment will have to be built and to be produced at the end. And for the reason, we need some realistic expectations. That is very important. And these realistic expectations are in the other side of the challenge, independently of how tough or how hard is the challenge. Take into account that at the end you have to be building some prototypes. This is not to scare you, just the opposite. This is to encourage you that you present your projects in. This is the 5 objectives, that 5 different fields, and not complementary or sometimes complementary, but it doesn't matter how complementary are those fields. The idea is that you present in any of these 5 objectives, and also independently on how deep you arrive to the end to achieve the objectives of each field. This is very important for us. Well, some annotations, my annotations, not yours. For me, when I'm thinking in robotics in this environment, you have seen the images are very difficult. And what you'll be visiting this afternoon is the most friendly area of the sewerage system. But at the end, not all the areas are so easy as that you'll be visiting this afternoon. There are more challenges or more difficult challenges that you will see this afternoon. When I'm thinking in robots, we'll be thinking maybe in wheeled, in crawlers, in amphibious, even in legged, or even in flying. Some solutions nowadays in flying robotic, swarm, amphibious, a combination of both, or well, it depends. It's up to you what kind of robot you present. And also you can be presenting an existing robot with your adapted software, or even you can present your own robot. But, it's up to you. There's some ideas. Also, the robot can be autonomous or teleoperated. Also, it's independent with cable or without cable. Don't be tied to the idea of being completely autonomous without a cable. You can be using a cable. The idea is open. More ideas about the sensors. Sewers is a very hostile environment. There's no light, there's no Wi-Fi coverage, there's no GPS coverage, and then any kind of sensors that you are thinking of, we use it navigation, any kind of inertial navigation system, and we use cameras, not only high definition, but also in low resolution also for navigation. And lasers, lidars, sonars also, some areas with water, audio, and also some actuators, not only sensors, but any kind of actuators could be in mind, any kind of manipulator. Also for special structures, those manipulators could be used for handling high definition cameras. Okay. It's up to you what kind of manipulators, if needed. Also take into account that one of the objectives is to take some samples of the sediments, and also you can be thinking any actuator to pick up the samples, the solid ones, the liquid, or even the gaseous samples to be collected. And well, finally, the environment is very hostile, and the environment cannot be modified. The CASA and the authorities won't be modifying the environment in order to put all your sensors on all the equipment that you need. The sewer is the sewer, like it is. And one of the things that we can do is to set some passive RFID tags. This also is possible. Take into account that at specific distances, a set of RFID passive tags, passive, never actives, could be set. Also, this could be help you in order to prepare your ideas or your proposals. Also, there is no light. Take into account that even an autonomous system will be running during several hours in the sewerage with high illumination. The battery consumption could be high. Take into account also this area. And well, wait a moment. The questions after presentation. Well, that's only my technical appointment. Nothing else. This is up to you. What technology? What kind of robot? What kind of sensors? The environment is closed, and closed means that only a set of passive RFID tags could be set on the environment, no more. Well, and also, I repeat, my idea is to encourage you in order to prepare your proposals. We'll be waiting for your questions during the call is open. We'll be answering your questions. You have questions about the sensors, the kilometers of the sewers, characteristics of the sewers. We will respond you in order that you prepare or you accommodate your presentation or your proposal according to those features. We'll be open to your questions. Well, I think that's all.
We go to some questions, or Albert, you want to say some words from the CASA?
Yes,
you are here. And
maybe I should have introduced my Jose before, but from the CASA, we are very proud to have been selected for this project. The CASA is the way we manage all the water cycle in Barcelona. It's a new public company that it goes from first this year, and we manage the sewage network, the fountain, the beach, even the river, the Sos, which all the control access there. The idea of the CASA is to manage all the water system in the city in an integrated way. That's the main objective. We are a very good team of people. We are almost 100 people, person. We manage the operation. We also do projects. We do the direction of the works. Always about the sewage network. And our budget is about 20 million euro each year. So our team it's very well prepared, and we will work to this project, ECHORD Plus, with a lot of force. It's a big challenge for us because to have a robot in the network working there, it's a big challenge. It's a new thing. It's something that we have to manage in a good way with our own people, because maybe some persons who are doing this work he will change the kind of work they will have to do. And I think it's also a challenge for the companies, a robotic challenge. You say. It's a very, very great challenge. So we are very proud.
Anything else?
Only to see that, as Jose and Albert said, what we already expected from the part of the operation, no? That we are the people who are all day in field, working with all the problems, with all the and we are very expected in your proposals, no, and in this project. And well, we are here to respond to some questions and some technical aspects, and in order to you can have all the information in order to proposals. No? Proposals, we are sure that will come.
Okay, thank you. Anything else?
Maria Luis.
May I ask you one question? Do you have already an idea about the diameters which are interesting for you for this view? Because you have outlined that there are quite good robotic solutions for smaller.
The diameter is more than 80 centimeters.
Mm-hmm.
Bigger than 18.
Many research has been done in pipes, from 40, 60, or near 80 centimeters. But just a few experiments have been done in high galleries, in 1.5 meters or 2 meters. There's no research or no commercial product right now.
For small sizes, pipe sizes, there are a lot of products now, and the result is enough.
Mm-hmm.
It could be improved the speed and the efficiency, but without our problem is in big structures, in galleries from this size.
Mm-hmm.
Visitables or semi-visitables,
Yes.
no?
A little man.
Yes. Because they are
80 centimeters.
in the medium size, not the size we have seen in the video, or not the smallest one, but they are in the medium that it's very difficult to go in, and with a very difficult, with a lot of risk, and it's one of the field that
The manholes are the only way to get the robotic system inside the galleries, or not?
Yes.
Because that makes,
Now, yes.
We refer to the previous, we only that the diameter of the manholes is only 70 centimeters, if I'm not wrong. But I can see also some stairs that are using for the men to go down. So this will reduce the diameter.
The stars that you
Yes.
have seen in the video
Yes.
are in the gallery, not for the access of the sewer network. It's part of the sewer
There
network.
were some stairs that I saw through the manholes that they were using to go down. No? So this reduces the diameter of the manhole.
well, but normally the manhole is well, the manhole, the round circle, when it's open and you go inside,
Yes.
and then the tube to go inside with the stairs, no? Well, normally it's a little bigger than the diameter of the axis.
Okay.
Is the Barcelona sewage system quite typical? Would it be applicable to all sorts of European cities in your experience?
This is very important.
I think in the characteristics of the sewer, it's a unitary, a combined sewer system.
Combined sewer
Yes.
and right in the water too.
Quite similar.
Basically, yes, are similar. No? Of course, there are other examples, no, that there are unitary systems, or there are separative systems, and of course are different, but in unitary or combined system. Yes.
Is it necessary to carry any underwater inspections?
The water?
Underwater inspections, is it necessary?
Well, we have seen that normally there are the part, dry part that you can walk, okay, and the lowest part where the water runs, the wastewater runs. But for example, there are in the last images that we have seen, there are in the big collectors that arrive to the sea. Normally there you can find that the water covers all the surface.
But the seawater.
Yes.
It's the seawater you have seen there.
Diguem, un hàndicap que per inspecció dels sifons seria un producte molt interessant determinar quin sediment tenim a dintre els sifons.
For example, there are other elements, no? The siphons, no? inside the network that are full covered with water, and could be a good element to see what are the waste inside the residual inside this kind of element. For example, these are currently flow water.
Aquests sifons són importants. Tenim fins a 300 metres de llargada. És a dir, evacuar tot l'aigua per fer una inspecció en 300 metres de seguiment.
These siphons can have 300 meters of length, and to empty all this water, it's a cost. But we have tools to inspect these elements online without.
Sometimes you have to cross a metro tunnel, and you have to siphon a long one, 300 meters, and it's always full of water. So it could be very interesting to.
But this is a singularity.
Yes.
Yes.
Well,
the big. We have a lot of this problematic that we have to clean and periodically to have to empty the water. Well,
Well, right now, this objective is not included in the functions, you can see. And also in my list of vertical robots, I haven't put any UAV. There are no underwater automated vehicles. But wait for the proposal. This is just a presentation. There will be a formal proposal, a formal presentation for the goal, and maybe we could add as a sixth objective. Why not? Why not? No, in order after this
just ask
discussion.
about the inspections, if it is necessary to make any inspections underwater.
Yeah, exactly. They say there are 300 pipes fully water, and maybe this kind of UAV robots should be necessary.
But of course the problem, the robot can of course have to go inside the conditions we have seen. No, there are water, there are 50 centimeters of water in bad weather, but it's a condition.
It's not clean water.
Yes.
So you said that it's okay to have robotic swarms, and I'm trying to contrast this with the for our autonomy. So is it possible to consider that the swarm is basically one robot and the collective autonomy is 4 hours? Maybe some of the robots can go at a specific distance in the swarm, some other can do the rest. I mean, like sharing this.
Don't be restricted for the 4 hours of autonomy. Completely. Okay. Don't be tied for this restriction. Put your own bounds. It's also interesting for us. This is what I say. I want to encourage you. That here, this is a top requirements. Okay, but you can put your own limits to the proposals. That will be accepted, at least for a study in the home.
Professor, I don't know if I missed before. How many times by day you have to monitor each part of the sectors? If you have to monitor every time, I don't know, time each day, segment,
Quantes vegades fem inspecció actualment? Una, 2 i 3 vegades l'any, depèn de la zona. Mínim una.
Minimum one per year in one specific zone.
Yeah, but Barcelona has three different slopes. And the high part of Barcelona, we have more pendiente. Slope. And the medium part of Barcelona is medium slope, and the coast part is very flat. So we can make the inspection 3 times a year in the lowest part, and 1 time a year in the highest part. It depends on the.
Okay, so it's possible to create a different zone.
Yes. Because in the coastline, in the flattest part is we have more
less critical for
sediment.
Okay, and
So-
touched on this one. So it means that in different zones we could have different critical situations.
Yes. Yes, near the sea, it's we have always more critical situations, even in smell problems. Also.
And highest debit, more the lowest part, the debit increases.
I think that's when you had a slide on the expected benefits. Could we? Is there an order here? Is safety and the well-being of the worker at the top, or how would these be actually structured? And the second part of that would be there's some of them. Let me see, the cost, reduce odors and overflows. Is that actually measurable from the solution which is to be put in place, or would that would be like a secondary consequence of the solution being put in place, perhaps?
I haven't prepared the slide, but in my opinion, all the entrance has the same importance. I think are not ordered in order of importance. It's not important to solve the first, the second, the third. No, for me, there is no order. I'm not sorted. For me, it's so important to have a real robot, another robot that can smell or reduce the odors, or to be cost effective. This is my opinion, but from the technical point of view. But I want to hear your opinions.
If you can improve the inspection and the cleaning of the sewer system, it's a consequence that is maybe reduce the odors and overflow.
As a general answer, I understand that the super robot, it's impossible to be done. A robot that smells to be underwater and high the slopes and so on, this is completely impossible. And we understand as techniques that one product like this, it's quite impossible or impossible. And then for this question, I want to encourage you in order that you prepare your proposal with your requirements, saying this robot will be able to attack this part of the problem and to reduce this question or this another. And then when you find your niche, try to prepare a very good proposal on your niche. If the niche is very wide, that will be better for the project. But if you prepare a very restricted niche that only would be working under these conditions, but under these conditions, the objective will be fulfilled in 100%, that will be perfect for us. Don't try to find the super robot that works in under any conditions, but only working at 15%. That's not good. We prefer a robot with very high performance, even though only is working under restricted conditions. I think this is a sentence for encouraging you to prepare your proposals. Don't find the super robot. Just find a robot that works perfectly under your conditions, but in levels of performance more than 95%. This is what we are looking for. This is what we set the realistic expectations. Be real, please, Maria Luisa.
But I mean, the target is to have a robot that solves the problem. So if we are concentrating on a specific part of the problem, let's say, because we cannot produce the super robot, it would be nice to have a solution that taps a huge potential part of the entire problem. So maybe we can also tackle this point when we are developing the challenge description. Give some background information on how the sewer network in Barcelona is composed, the different environment aspects, and then if we have to concentrate on a niche, which I agree is something that there will be some restrictions, would be good to concentrate on those parts which solve the problem to a high extent. just as a comment from my side, because what we want to have is a product that can, or something very close to a product that we can exploit afterwards.
Exactly. At the end, we are looking for a product that could be exploited, produced, and not only working in Barcelona, but also in all the European cities. Your question about the sewerage systems. The sewerage system in Europe is completely different in the United States, for example. There are new cities. When you are planning a city, you are really planning a sewerage system also. Here we have some sewer systems from the Romantic age. And the circumstances are completely different.
Our sewage network system, for example, is different than in North Europe, because here we have Mediterranean climate. It rains a lot, sometimes, few times, and so on. We have also now a lot of tourism in Barcelona, and so we are very. We have to manage very well all the other problems. So for us, it's also very interesting this robot to detect hydrogen sulfide and methane, because it allows us to detect the other problem. And we have a lot of demands of citizens about problems of others. So if we can detect that in a scientific, in a technical way, it must help us a lot.
So just one additional idea that came to my mind. If you are submitting your proposals and you are concentrating on a niche, would be really, really very interesting for us to know the scalability. So if you have a solution for a specific part of the problem, it would be really, really nice to know what has to be done on top to solve other parts of the problem as well. So that potentially at a certain point we have a full solution that can solve the entire problem. And if you could explain that in your proposals, scalability is a very important thing.
Thank you very much, Luis, for this one. Is important. The last question.
Yeah, I think an important part of the success of the project comes from the integration in the operations. And do you have any feedback on what your operators expect, or in terms of logistics, but also in terms of operation, is direct interaction with the robot, if there should be any, and how do you expect to receive this data?
Well, we expect that the robot arrives maybe in some areas or some problematic areas that there is a risk for the people that go inside, and the robot can arrive to these areas, for example, and to avoid that the people who work inside that go inside the network in these cases.
No, but I think it's a very interesting question, because we are now working with the CASA in one side of the table and with robotics researchers in the other side, in order to arrive to a description of the challenge that could have solution. And this is our work during the last month, and we will keep on in this kind of meetings. I think they are very nice, and we have not we have not discussed about that perhaps the robot is a robot that an inspector is carrying with him, and use it only for some situations, some dangerous situation, risk. We are speaking all the time around autonomous robots that you leave. No, you blah 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 blah. You go down, and the robot go very autonomous. We are speaking about autonomy and these kind of things. So this is an idea I think is very important to know also. If the relation between robot and inspector could save us some of the objectives that we have.
We are open.
Yes, yes. This is the both system. Yes, it's very interesting. Yes.
But anyway, we are looking for proposals that go further the state of the art. The state of the art right now in several systems is just a camera aboard a crawling robot with a cable sending images to a monitor and someone in a van monitoring the images. And you arrive with a big sediment, the robot stops, and now it's recovered again. No? We are looking for something beyond the state of the art.
Perhaps we can prepare, Maria Jose, a case study that, for example, in healthcare, you have prepared a history, no? A history about the inspector, a history that give us the information about what the inspector is doing. We have seen perfect in the video, but perhaps the different facilities, the different.
Spend the day with inspector.
Yeah. Yes.
It's an use case.
It's an use case in order to know the history of them.
One day
we was a question. There's a question.
Yeah, but I think you answered that. I think you already answered that, because I was going to go further on his question. I said if you were expecting to have for instance, the images or the data in real time, or you expect the robot to go back and download information somehow?
It depends on the ability of the robot. It's not necessary to have images on real time. You can store the images in some hard disk, and you can start recording high definition for hours in a disk of terabytes. Why not?
Yes, so then you are not expecting to control the robot.
Could be self-controlled. Could be self-controlled. You can be doing some SLAM and some creation of any kind of map that the robot is able to know its location in the map. Why not? Because it's open. Don't narrow your mind. It's possible.
Now, because it was mentioned that the cost of the inspection is something important. So, do you expect the robot to be able to perform high-level planning of the inspection, or a high-level plan will be provided from the users, from the inspectors, for the robot to perform? Or is it something that the robot has to plan its own?
This is in the area of cartography, I understand. Huh?
Yes.
Well, right now there's a map of the sewers, and the maps is not very well cartographed. There's some problems on the cartography.
It's very well.
No, it's very well, but there are some singular elements that is necessary to improve. We have all the cartography of the city of Barcelona. It takes a very long period since the Olympics, maybe from now. There are and before there are hard works for this part, but sometimes there are big infrastructure that is necessary to have more detailed information. And it's in this order, the cartography, that we try to explain.
Okay, so I guess some parts of the sewer infrastructure have greater importance, or they need more frequent inspections than others.
Mm-hmm.
So this can be implemented as a high-level protocol in the robot, or the inspectors can provide this information. I mean, what is your approach? You want it to be implemented in the robot, or the robot has to decide it by itself based on some information, or you want to give it? This is about the high-level planning that I'm asking. I want to understand what kind of high-level capabilities the robot would have.
I think both things would be interesting and possible. No? Of course, we have information, and what the idea is to the inspections objectives is to know or to have knowledge of the network and the state of the network. No? And the robot can help to, I don't know if you are thinking in learning, no, in some learning, or that the robot is autonomy and have capacity to decide.
Mm-hmm.
Well, it could be, but the idea is that you say the robot, which is
I think the knowledge of the network and the sewage, it's from people. So I can see more a robot that has a specific instruction in a specific area, that a robot that can decide by itself. So, and sometimes you have a problem, not of sediment but of oil, and sometimes you have a problem in an area that you have a lot of tourism and not in another area. So I think the inspector know the network, and it's difficult to translate this decision to the robot, I think. But maybe
from the technical part, there is a way to do it. That's why I'm
other thing is you can say to the robot, you can pre-program it, which is the yes. Okay, you can say, okay, today I'm interested that you go by here, by here, by here, by here. And you pre-program it, and then the robot goes alone and arrives to the place, and then or come back, or you go there to take the robot. No,
all the sewer system network is categorized in a geographical information system, and we can order to the robot go there or the other country. It's possible both.
Or if the robot loses, no, you lose inside the. He loses.
Where is the robot?
Yes, where is it? So you must, or we can be able to localize the robot, or come back, or recalculate the.
We can go to the street.
So in order to avoid this, there will be some RIT tax.
Yeah.
And in some specific areas of the sewerage system. Please, Maria Luisa.
If you have two different options of doing things, I mean, another question that I would ask myself is the cost effectiveness. So which is the cost reduction that you achieve with which solution?
Okay.
And if you find out that it is better to have an inspector included in the entire running system, because the cost effectiveness is still higher than having a completely autonomous system or something like that, this would be something that I would tell you that.
Okay. Last question.
Another question. I mean, as cost effectiveness is an important thing of the project, and there was also maximum price of the inspection once the robot is put down the sewer. I wonder if on the technical details that you will be writing, so that it will be available in 1 month, now you said, there will be information about economic costs of inspection, so people offering robotic inspection can evaluate which is the savings that the robot will offer. No, it's a question.
Yes.
I think should be.
Okay.
Okay, well, I suggest that you wait for the call, and we'll be very glad to answer all your questions when the call is open, in order to help you improve your proposals. Thank you very much.
Any public presentation from the people we have here? Yes, yes. We invite you to present yourself in order to create consortiums or to know each other. And you are welcome to this table. Perfect. Perfect.
Sí, 30 segons, 35, perquè potser 30 segons no t'agafa, no sé.
So good morning. So my name is Josep Maria Mirats. I'm the founder and the chief executive officer of a company which is based in Barcelona. The name of the company is Inloc Robotics, and we are specialized in offering solutions of localization and navigation for autonomous robots. So we are very interested in this problem and have experience in a lot of robotic problems that we have worked in the past. Just for you to know our company. Thank you.
Give us your, can you give?
Yes, my web page, it's web in loc is inspection, EIN, loc is for localization, so LOC, robotics, altogether.com. So you can have the information of our company there.
Thank you.
Sure, thank you.
So, hello, my name is Irene Carlos, and since this morning we were told that we may be able to do a small presentation,
Do you have it?
I have it here, so I'm going to make a small presentation. I work for a Spanish consultancy. We are based in Madrid, and we provide consultancy for the water and the ICT sectors. So, it's not what I see in the screen is not what is there. Oh. It's okay. So as I say, we are a consultancy in the water and the ICT sectors, and we belong to a group that is a TPF group, and on the map you can see all the locations where we are. So, but coming back to AFIN, that is the water and ICT consultancy. Here you have an overview of what we do. Regarding the hydraulics part, we do engineering services for planning, operation, and control management of water networks, either supply and sanitation, either wastewater network, which is what is interesting here. We do hydraulic modeling, and we work with decision support systems and operator performance auditing. And regarding the ICT, we have a telecommunications department. We specialize in wireless sensor network, control and data collection, and radio spectrum management and planning, such as smart cities and satellite networks as well. But what I think is interesting here is that we have great experience working on the sewer network. We do hydraulic modeling, where we use data from the CCTV. That's what Anthony was mentioning, the CCTV with the cameras and the wire in the van. So we use it. And we also work on leakage detection and localization services, do on-site surveys for the GIS. So we do the inspection of the sewers. For doing the inspection of the sewers, we currently use WinCam. We are suppliers of WinCam, but what's important here is that we help them with the definition of the requirements for this. So, and I think if I understood properly, that what the CASA is asking here is for a huge upgrade of what we have right now, of what most of the sewer inspectors are using. So we can provide with the knowledge of the sewer system of very different cities. In between them, we can include that we have some very slight knowledge of the Barcelona sewer system, and many other cities with their own problems. And regarding the communications, I think there might be some useful skills here as well, because we have experience on the data analytics, for instance, or decision support systems, also on the inputting the data into the GIS system. And I think that's all. And also as well, we have experience on European projects, so we can provide with experience with elaborating the proposals, and we are used to work with the European Commission, so this is also something that we can bring into the consortium. So there are my contact details over there, but I have cards as well that I would like to give you later. So if you find us interesting. Thank you.
Thank you, Irene. Thank you very much.
First of all, let us introduce ourselves. We are here. There is Dr. Anthony Justa and Dr. Cesar Galvez from Fundació Sant Antoni Abat in Vilanova, Gavà, no? And I am Caterina Sampol from Aquas, from an agency of the healthcare department. We together will try to lead the challenge with Marie-Louise and all the ECHO team. And on the 3rd of December, we will have another market consultation in Munich, where, like today with Sewer, will be a deep insight in our challenge with more technical aspects of the challenge. But we thought that it would be useful to show you our challenge today. Well, what is the comprehensive geriatric assessment? It's an intensive and interdisciplinary process that aims to assess the functional status of the elders. And it includes a lot of aspects of an elder functionality, like psychological, psychical, economic, environment, behavior, the cognitive capabilities of the elder, and things like that. That means that the multidisciplinary team is really neat for this assessment. So, but this is a process that is very, very large and can involve a lot of tests, but is the most useful tool we now have to planning the elder's care, a personalized elder's care. And we have found, not we, the world has found that there are a lot of benefits with this assessment for patients, mainly, because they are given the right clinical treatment and diagnosis. And they have also greater functional autonomy at hospital discharge, because with the assessment, we know what exactly fits to that person. And we also find if there are contradictions with the drugs they are having to take and the treatments they need. And we decide, the multidisciplinary team is deciding which are the best for this patient, no? And well, also they have less need to income in nursing homes, so we can say that the life is better, no? Improves their daily life. But furthermore, there are reductions in the system, because the complications like deliriums and inpatient infections are reducing very much with this kind of team approach. And also the mortality decreases very much, and the costs, the overall costs are reducing very much also. Well, as I told you, this assessment includes a very wide range of tests that now there are no robotics included in these tests, and we are aiming for introduce robotic in these tests, and to improve, of course, the health outcomes for these frail elders. Well, why? Simplifying evaluations, helping us to improve diagnosis and therapeutic decisions, increasing quality of our results, and also we want to integrate the robotic in the process by getting scoring and coding data from patient during the whole process, and also displaying results and recording the patient with audio and video during the whole process. That will free resources from our team, and then that will allow also this team to have more accurate data to have the core diagnosis. So I don't know if you want to add something. You are the experts in geriatrics, so.
Thanks, Lorena. We came a group in two main benefits if we get to be able to include or involve some robotic device in that process. We spend a lot of time in that all the tests we need to do with the patients. We usually spend more or less 50% of the time doing the test. We're filling the data in the computer. We need to interact with the computer and not with the patient. The patient a lot of time is waiting for us, but we need to do some tasks with the computers. The time is one of the most important problems for us during the usual clinical practice. The other issue we can improve, including a robot device, maybe the quality of the clinical interview, because we spend time seeing the computer, seeing the machines, the devices, and we lost the direct visual contact with the patients. And the patients at the end of the interview many times have the feeling, I don't know, the interview was between the doctor and the computer, but they didn't see me. It's a real problem we have currently with the usual practice. The challenge may be focus in that two goals to perform a robot device who can or who is able, which is able to register or to do tasks which we usually do with the computer.
That's our introduction. It's only a bit of what you will can know better in December in Munich.
Maybe just one, there will be live streaming as well. So if you are not available for traveling again, you will get, I mean, if you are interested, you can contact us and we will give you the address, the access, and you can take a look at what we are doing in Munich on the 3rd of December.
Yes, also everything will be available in the ECHORD website, so we will have updates of everything.
And also a video on the challenge will be available to explain.
Yes.
That's one question. In your presentation, I don't have really clear what is the final outcome of this. I mean, are you looking for adding new software capabilities to existing platforms? For example, the Peer 2 that appeared there, or the Robot from the Fraunhofer Institute, which are really big, very nice robots which can interact with other people, or you are looking for very new and different hardware platforms itself?
We are not looking for a platform. We are looking for something for us is that help us during the assessment, during the whole assessment. We want to be looking at the patient, and we need to be sure that there is something that is recording everything, every data, everything. And also, maybe if it is something user-friendly for the elders, it can interact with the elder, but it's not necessarily something that is
yeah, but that can be based on an existing thing. I mean, for example,
yes, of course, yes.
You know, the parosine.
Yes,
Now
yes,
the systems now is in the therapy, but not in the diagnosis.
Yeah.
Now, but we think it's very interesting the interaction that these devices. But the elders, your opinion is their opinion is the devices is no anthropomorph, no more
intelligent, no?
No, it's with errors.
Yeah, with errors. It has to have errors.
It's similar to empathy, but no small, ni very big. It's very interesting that the robotical is near to the professional with the patients, with the family in the site.
May I add? Yes, you can use whatever technology you would like to. As long as the challenge is completed, the need of the public body is fulfilled, and the cost restrictions are respected. So it's more or less the same approach as we have seen today. We'll have in Munich, we'll have someone who from the medical field will explain in detail what exactly the problem is and which kind of, or for which we would like to have a solution. And you will also have, with the challenge documents, you will have the possibility to calculate the cost effectiveness. And if a hospital is willing, or you think that a hospital is willing to do the investment in buying some sort of devices which are interacting with the patient and that solves the problem and it is cost effective, you can propose that.
Yes.
So, from what I understand, correct me if I'm wrong, what you are looking for is something like a user interface, basically, a more maybe evolved user interface to serve as an intermediate between the patient and the doctor. And it's
an
not,
assistant. An assistant.
And for me, it's not clear that this thing should be a robotic thing. It could be a software.
No, it will be a robotic solution because it is a robotic call.
Yeah.
That is the restriction that we have. It will be, it is something we are running a robotic call. The intention is to use robotics technology for specific challenges. We have had 89 people in healthcare. We have robotics experts selecting the challenge, and this is the challenge that has been selected. And what we are looking for is robotics technology to solve the challenge.
I mean, it is not clear for me where the robot comes into play here.
The robot comes during the whole visit and the whole assessment can be in the hall. Is at the beginning when the patient is coming with the relatives or the person that are with them, collecting the first data and answering some questions that the robot are giving them, and then to being the colleague of the patient with the team, because it's a multidisciplinary team, and they will have to pass several tests, and this robot will be a recording, maybe.
A new professional is the robot.
Yes, is a new member of the team that will be the whole time with the patient. That is our ambition.
If I would, let's say, think about submitting a proposal, what I would probably do is to analyze the cycle of the different tasks that are completed and the time that is needed for the different cycles. And then the question is where you can use the technology in order to save more time from the professional staff or the patient, and to take the therapy or the recording load and so on and so forth from the professional people, so that they can spend more time with the patient and also reduce the time in total that they have to spend. So this is really something where cost effectiveness is really, again, an issue. And yeah, so this would be probably what I would do. I would take a look at the circle of different activities and then try to analyze where I could have the most important impact.
And that's why we will record the cycle of the assessment, because it's good to have a look of what are we speaking about.
The assessment will always be performed in a hospital environment. There's no requirement for it to be.
No, for us is a help for the hospital assessment, no? Not at home. But if you have some idea, we are open also, no, Marie-Louise?
Absolutely, yeah, absolutely.
Yes,
so what we will, I mean, according to my perception of the situation, what we would like to have is a robotic solution at the end, which frees, to a certain extent, the professional staff for having more time with the patient, and all the activities that can be taken over by any kind of robotics technology should be, let's say, taken away from the professional person and be done by a robotic technology. And then the question is how the investment that you have to do as a clinic at the beginning, the return on investment that you have. So this would be the kind of ideas that I would have when I was thinking about submitting a proposal. So it is really something that we want to implement, exploit at the end, which brings cost effectiveness and increases the value for the patient. That is, I think.
Just maybe the last question. So it means that there is not an expert system behind for get some decision. It's the final decision
is for the team, because the team will evaluate what is the best way to diagnose the patient. For sure, maybe there will be two drugs the patient is taking that one of them are contradictory. So this decision won't be in the robotic side, will be on the multidimensional, the professional.
Because when you speak well, or maybe for simplifying evaluation, so it means that you have not to have some have to collect some objective data, not subjective data. No? It means imagine if I get the interview of the patient, I can understand directly from him what is saying, instead of some other people in the middle that say something, maybe understanding wrong some words or something. You know?
Well, there will be also, but when the patient arrives, maybe a first little check of questions can be fulfilled. No, maybe if the robot is friendly enough, can establish an empathy with the patient. I don't know. That's what can be imagined, no, all around in this sense. But it's something like that. Not to interview the patient. The interview will be, the real interview will be done by a specialist in each of the fields of the assessment. But the robot can help in the whole process.
Now there are software in Interlight. It's software, objective software for the making this decision making. Okay, but I think it's another situation. It's the interactions. A new professional is the robot in the team for evaluation.
Well, we are expecting you in Munich.
Questions?